All right, today we're going to cover a lot of stuff like how to recognize acids and bases. We're going to talk about neutralization. We're going to talk about acid rain, and we're also going to talk about characteristics. So just hold on tight. There's also videos throughout this presentation, so please pause and stop and play the videos. I think you'll find them entertaining, but also educational. So let's go ahead and get started. Go ahead and turn to page 1, and you're going to go ahead and fill out this notes from class part right here. And if you have something up above from your reading that's the same, don't feel like you have to write it, but you can go ahead and pause the video and then write down what you need to write down and then come back. Okay, so first of all, here's a lovely picture of some acidic items. A lot of our foods are acidic. Okay, not sure why that's happening. Okay, so here's some characteristics of acid. They have a sour taste. They change the indicator that we used in the lab the other day. They'll change a blue litmus paper to a red, like it's showing right here in this picture. They react with metals to release hydrogen. So what's happening here, like yesterday in the lab, we had hydrochloric acid. We added it to a metal. And then what happens is this hydrochloric acid breaks up into a positive and negative charge, and we get magnesium chloride. Oh, sorry, we don't want that right there. We get magnesium chloride, and then we get hydrogen gas. So in the lab yesterday, when you put that piece of magnesium in the hydrochloric acid, you should have hopefully seen bubbling or some fizzing, and that was the hydrogen gas that was being given off right there. Okay. Another thing that acids do is they can react with a base to make a salt and a water. They can also conduct electric current because they break up into ions. They break up into a positive and a negative charge like we're seeing up there. And then acids will donate hydrogen ions in a solution. So a characteristic of acid is the fact that they have these hydrogen ions, which is why that positive sign is right there. Okay, then we have a little video, so go ahead and pause that and go ahead and watch that video. And sorry, I don't want you to watch it. You don't need to watch it with me. Okay, then characteristics of bases. Bases have what we call a hydroxide ion. That's this OH with a negative charge right here. This is a hydroxide. And they have a bitter taste. So the best way I can explain this is if you have like some kind of medicine for headaches or body inflammation like ibuprofen or aspirin, and you taste the inside, or maybe the coating rubs off, but it's super, super bitter. Some foods that taste like this are mustard has a bitter taste. Some of your vegetables, if they don't get enough water when they're growing, like lettuce or sometimes cucumbers, they become really, really bitter. Or like saltine crackers that have baking soda in it. Those also have a bitter taste to them. Or chocolate that's a higher concentration of cacao in it. So it's a darker chocolate, like 70% and higher. That also has a very bitter taste. So as far as the lab goes, an indicator that we use is the red litmus paper. And it will change the red litmus paper to blue, like you're seeing in this picture right here, if it's a base. A lot of bases are cleaners. And so what happens is they feel slippery. So for example, if you're using window cleaner and you go and you wash off your hands because you have some window cleaner on your hands feel slippery. And that's because window cleaner is a base. Your soaps are also base, and so that's why those feel slippery as well. Again, bases will react with an acid to produce a salt and water. They can also conduct electric current like acids because, again, they break down into a positive and a negative charge. And they accept the hydrogen ion in solution from the acid. So those are a little bit of characteristics about bases. Okay, so those are some pictures. Another thing that bases are known for is to neutralize acid in your stomach. So the acid in our stomach is hydrochloric acid, and it's a very strong acid. And so we can use things like Tums or even baking soda to help neutralize the acid in our stomach. So if we're eating really fatty foods like meat, like high-fat meat, cheeses, cheesecake, chocolate, it can produce more acid in our stomach because our stomach is trying to break down that fatty food. And when that happens, sometimes we get, oh my gosh, how come I can't think about it? acid reflux, where the acid comes up into our diaphragm. And so we'll take things like Tums or baking soda or like Pepto-Bismol or milk of magnesia, and it helps counteract the acid because you're using a base now. Okay. So here's a little video. Go ahead and watch that when you get a chance. But I don't know why that keeps happening to me. Okay, then now I want you to turn to page 6, and we're going to answer some of these questions on the top. So first of all, acids and bases are electrolytes, and I've kind of mentioned that just recently in this lesson. So what is an electrolyte? So maybe you can pause the video and think to yourself, what is an electrolyte and why are acids and bases electrolytes? Okay, welcome back. An electrolyte, remember, is a compound that has a positive and a negative charge and conducts electricity. So if you remember in our demo with our light bulb, I put in hydrochloric acid and it lit that bulb up, and that's because it's an electrolyte. So the reason why acids and bases are electrolytes is because they break up into a positive and negative ions. So right here we have an acid. That HBr is an acid. Notice how we have the H positive right there. This NaOH is a base. Notice how we have the hydroxide right there. And notice how they are both breaking up into positive and negative charges. And they are in a solution, and so they have the mobility to create the electricity. Okay, so next part. This is on number 3, patterns for recognizing acids and bases. So an acid is always going to have a hydrogen ion, and 99.9% of the time it's in the front. So we have a hydrogen ion, and we're going to bond that to a nonmetal on the periodic table, or it could have a hydrogen ion plus a polyatomic ion, and you're going to have one that's a negative polyatomic ion. And so again, you're looking for hydrogen in the front with a nonmetal attached, or hydrogen in the front with a polyatomic ion attached. And again, 99.9% of hydrogens have this formula. Okay, the bases, there's a lot of different bases, but the formula I want you to know is this one. It's going to be a metal that's bonded to a hydroxide ion. Okay, like I said, there's other types of bases, but this is the most common type of base, is a metal with a hydroxide ion. All right, so now we're going to play a little thing called, is it an acid or is it a base? I'm going to go through these, and as I go through them, I want you to go ahead and fill out on page 6, numbers 4 and 5. And then think about whether or not it's an acid or a base. Okay, so this, acid or base, this is an acid because it has a hydrogen and a nonmetal. Okay, next one, oops, NaOH, you've got it. This is a base. You have a metal with the sodium and the hydroxide. Acid, base, acid. This one has a hydrogen, and the PO4 is a polyatomic ion. Right here, this one's kind of tricky. This is actually an acid, and the reason why is because you've got the hydrogen here, and this part right here, this is called acetate. It's a polyatomic ion. The only reason the hydrogen's in the back here is because of our Lewis structures. When we draw out this structure, this last hydrogen right here is right here, and so they put it on the end to help draw out the Lewis structure. So this is called acetic acid, and this common name for this is vinegar. Okay, so that is an acid. Okay, let's do some more. Okay, this one, KOH, you got it. This one's a base. And again, another base. We have a metal here. Magnesiums are metal, bonded to the hydroxide. This one is an acid. This is called hypochlorous acid. HI, oh, this is the friendliest molecule of them all. And you've got it. This one's an acid as well. This one, again, another acid because we've got hydrogen, and then SO4 is sulfate. So this is called sulfuric acid, and this is the most commonly produced acid, and the reason why is because it's used in batteries, like car batteries. And then this one right here, this one's tricky again. This one is actually a base. This is called ammonia. So this is the only other base I'm going to have you know, and it's a weak base, and ammonia is what we use in fertilizers and also in window cleaner. It has a very distinct smell, so that one is a base. Okay, so hopefully you got some lists there on 4 and 5. So again, these two are exceptions. This one again is called acetic acid, which is vinegar. So this is our acid, and then this right here is our base called ammonia. So make sure you know that those two are exceptions to our common pattern of an acid and a base. Okay, now let's talk about neutralization. So we're down to number 6. Okay, so go ahead and write this down. Here's your word equation for neutralization. We have an acid plus a base, and we get a water plus a salt. And so if you notice right here, if we add an acid to a base, we get the salt water. If we have the same amount of acid and base, like for example, like we have 20 milliliters of an acid, and we have 20 milliliters of a base, and it's the same concentration, like this is 15 molar and this is a 15 molar. If you put it together, you'd actually be completely safe to drink it. It's just going to taste super nasty because it's going to taste like salt water. If you were to drink a strong acid or a strong base by itself, it would actually burn your throat and down to your esophagus, and you could have some huge sores in there. So don't ever do that, and you should not drink an acid and a base combined anyway because it's nasty and not safe in the sense that, you know, what if something is inaccurate and something goes wrong? Okay, here is a formula for an acid and a base neutralization reaction. Right here, this is your salt. And your salt, the acid, okay, supplies the anion. So right here, here's your acid, okay, and here's your base, here's your water, here's your salt. So if you notice right here that your acid supplies the anion, and anion, remember, is negative. Remember the word anti kind of goes with anion. So this is your anion right here, and it goes with the acid. That's where that comes from. And then you'll notice down here the base comes from the cation, and the cation here is the sodium, and that comes from the base. So this is a very good test question that you could possibly be asked, hint, hint. And it's talking about how a salt is made, and a salt, again, that cation comes from the base, and the anion comes from the acid. Okay, so let's look at another example. That's a very common one. So here's another one. I want you to pause the video and identify what's the acid, what's the base, and what's the salt. Okay, welcome back. So hopefully you have figured out that the base is this calcium hydroxide. The acid is the HBr because you have a hydrogen with a nonmetal. Oops, didn't mean to do that. Go back. Okay, the base has a metal and a hydroxide. And then of course here's your salt. And the salt, again, if you look at this, the calcium is coming from the base, and the bromine is coming from the anion of the acid. So that's why that's a salt. Pretty cool. Okay. Then right here, this is just a diagram. This is just showing your stomach. Your stomach, the acid in your stomach is HCl, like I kind of talked about a little bit earlier. And your stomach lining is what prevents that acid from making holes in your stomach and going out into the other organs of your body. And that stomach lining is a mucous membrane. And so again, fatty foods or stress can produce too much acid, and sometimes it creates holes in this lining, and that's when we get like acid, well, that's when we get ulcers, is when we get a hole. Or sometimes if we have too much acid, it will come up and it'll go into here, into our diaphragm, and this is when we get our acid reflux. And so that's why we have things like Tums and milk of magnesia. Pepto-Bismol is to help neutralize the acid in our stomach. So our stomach is really, really cool because our HCl, our acid, that hydrochloric acid, is about a pH of 2, which is pretty low. Okay, now for the next questions down here, 8 through 12, what you're going to do is you're going to watch the following videos. I'm going to give you 2, and in those 2 you should be able to answer 8 and 9 and maybe question 10. And then tomorrow in class we'll watch the rest of the videos before going in and doing the lab. But this is really cool because it explains and talks about like how acid rain forms and why do we even care about acid rain and how can it be prevented. And so go ahead and watch those videos, pause them if you need to, and answer those questions. Okay, have a good day. Bye.